What's up, algebrats? We're going to talk more about systems of equations, and we're going to talk about how to test if something's a function or not. We talked about that previously, but we're going to do some more function tests. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 87. Here's how we're going to start. We're going to do more on systems of equations. So let's get some more equations in here. Let's say RETE equals RWTW. Also, RE equals 200. RW equals 250. And then we've got TE not equal to something, but plus TW equals 9. So we have 4 different variables. So in the past, they gave us 3, or at least gave us, said that RE equals a number, RW equals a number, and then TE equals an expression. We don't have TE equals something or TW equals something, but we can make it that way. We can manipulate this equation to look like this. We could say that TE equals, if I get rid of this, then I just have 9 minus TW, okay? So I could say TE equals that. Now I can plug this guy in right there. All right? I could have gotten TW by itself too. I could have said TW equals 9 minus TE. It doesn't matter which one you do, you're gonna end up with the same results. So let's rewrite our equation with our substituted values. So RE equals 200, so I'm going to plug in 200 right there. And then RW equals 250, so I'm going to plug in that right there, okay? So RE is 200 times my T of E, which is 9 minus TW, equals RW, which is 250, times TW. And that's the only thing I'm not given, so that's my variable. So, how do you solve equations? Simplify both sides first, get rid of parentheses. 1800 minus 200 TW equals 250 TW. Okay, both sides are simplified, so let's go on to step 2, solving equations, which is, if you have variables on both sides, get rid of the smaller one. Well, negative anything is smaller than positive, so add 200 TW to both sides, and you get 1800 equals 450 TW. All right, next step is get rid of constant on variable side. You don't have that, so we're going to skip step 3 and go to step 4, which is divide by variable's coefficient. So we're going to divide by 450. So 900 goes into 1800 twice, so 450, which is half of 900, would go in 4 times. So there's your TW. The directions say find TW and T of E. All right, so if this equals TW, now you can plug that into there. So TE equals 9 minus whatever TW was. So TE equals 5. Boom. All right, let's try another example. Here's example 2. Let's see, R1, T1. Ooh, yes, we get to say this. R2, T2 equals 360. What else do we know? Well, R1 equals 30. R2 equals 40. And then we get this thing, T1 plus T2 equals 10. So we have 2 options. We can get T1 by itself or T2 by itself. I'm going to get T1 by itself. So T1, if they add together to get 10, T1 is going to be 10 minus T2, or just get rid of T2 on both sides. So now here's our T1 value, so we're going to plug that in right there. Okay, and then our R1 is 30, so that goes right there. And our R2 is 40, so that goes right there. So let's rewrite these guys. R1 is 30 times T1, which is 10 minus T2, plus R2, which is 40, times t2, which is our only variable now, equals 360. All right, simplify and solve. Distribute. 300 minus 30t2 plus 40t2 equals 360. All right, next step to simplifying both sides is combine like terms. So 300 minus this negative 30t2 and positive 40t2 ends up with a positive 10t2 equals 360. Next step to solving equations, if you have variables on both sides, get rid of one. You don't. So go to step 3, which is get rid of constant on the variable side. So we're going to get rid of this 300. So 10t2 equals 60. Last step, divide by variable's coefficient. t2 equals 6. All right, so if t2 equals 6, what does t1 equal? t1 equals 10 minus 6, which is 4. All right, so those are your 2 t's. You got it. Good job. Okay, the next part of this lesson is another test for functions, okay? So remember, when we had functions like this, like when we had 3 going to 5, 4 going to 6, 5 going to 7, that was a function because the 3 only went to 5, 4 only went to 6, so there was only one y value for every x value. But if we added another one, like let's say 3 goes to 8, well this time 3 would go to 5 and 8. So when you graph this, 3, 5 is right here, 4, 6 is right here, 5, 7 is right here, and then you have your 3, 8, which is right here. Okay, well that doesn't work. You have multiple y's for the same x. So I'm gonna do what's called a vertical line test. The vertical line test says if you can draw a vertical line and it touches 2 points, then it's not a function. So look what happens. If I draw a vertical line from here to here, see how it's touching 2 points. So it's not a function, okay? Let's try some other examples so you can see what I mean. Okay, that's my function. Now, I can try to draw a vertical line anywhere on this, and it's not going to touch more than 1 point on that graph. So this is a function. So this is a function. Yes, it is a function because it passes the vertical line test. There's only one y value that every x goes to. So we're good. All right, let's try another one. Let's say this is my function. Bloop. Do you think that's a function? Well, try to draw a vertical line and make it touch more than one place. You can't. Okay, look at this. If you draw a vertical line right here, it only touches one right here, one right here. It's only touching one part of that graph every time. Now, for some reason, that one came around like this, then it wouldn't be a function because it would touch multiple y's for every x. But that's not what it is, it's just this. So, what's the verdict? Yes, it is a function. Okay, all right, let's try another one. Let's say my function looked like this. Uh-oh, what is that? That's a circle. Does the vertical line test work? Well, let's see. Let's draw some vertical lines. Look at that. It's touching more than one place every time. So this is not a function. See how it's touching multiple y's for every x. So we're going to say no, not a function. How sad for the circle. All right, let's try a couple more. What about this guy? Yes or no? Correct. No. Because look, if I drew a vertical line, it's touching multiple. It looks like a dollar sign kind of. Okay, so this is no. All right, what about this one? Okay, and this goes on forever and ever. Well, all you need is one instance where it's not a function. Look at this. See how it's touching 2 parts? So no, this is not a function either. All right, that's basically lesson 87. Well done. Good job.
Flack math! Give me some math and I'll give you some flack. Flack math!